Can you hear me?
Yes, sir.
Cos of t plus cos of t plus cos of like that they give A, B, C, D, and they give two more functions which are obviously not periodic. E power is exponential, they give minus omega square t square. The sixth question they give 1 plus omega t plus omega square t square. By first glance, we can clearly say which are non-periodic functions. Can you tell me which are non-periodic? By just to glance, we can say that these are non-periodic. Which of them? This is non-periodic. This is non-periodic. Because exponential and exponential functions are non-periodic always. You no need to even check them. No need to even check them. They are always. You don't have any repeating entity. So if they're non-periodic, they are not. There is no chance of SHM. So only we have to check these are non-periodic functions. What about the 1, 2, 3, and 4? We have to do. Question number 1 is sin omega t minus cos omega t. Same type of question we did earlier, an example problem. What is the period of sin omega t? Period, time period. 2 pi by omega. Time period. What is time period of cos omega t? Same. 2 pi by omega. So the LCM of both of them is what? Periodic. 2 pi by omega. Yes. So they are periodic functions, no doubt about it. It is a periodic function. This whole thing is a periodic function. But is it SHM or not? How do we know whether it is an SHM or not? How we did that? Whether it is SHM or not, how do we did? Remember how we did? We have to convert this. We have to convert this into a single function. And then only we can know whether it is SHM or not SHM. Remember how we did?
Yes, sir.
What we have to do, how do we convert it? Multiply and divide by 1 by root 2. That is the most easiest and simplest way to convert a given function into periodic function or not. We did that earlier. Same thing we are doing now. Earlier we did this.
Yes, sir.
1 by root 2 will multiply by. What do you get? Sin omega 1 by root 2 means what? Sin pi by 4 or cos pi by 4. We can use any of them. Better to use cos. Sin A cos B minus cos A sin B we call it. These are all there in maths and standard. We can call this as cos pi by 4 into sin omega minus what? Sin pi by 4. So if you see sin A cos B minus cos A sin B, what is that going to be? Sin A minus B. B minus. We did this earlier. It's there in your example problem also. Same type of a problem, but there plus was there, here minus is there. That's the only difference. Yes. So is it periodic? Yes, of course it is periodic. Is it or not? It is periodic. How do I infer that it's periodic or not? Is it periodic or not? Yes, it is periodic. Yes, okay, 10 minutes for break. Yeah, no problem. Half an hour break also, no problem. We started at 4:30, no? Also 4:30 to 5:30. 6 o'clock we'll stop. 6:30 again we'll start. Is it okay? So this is a periodic function or not? Yes, of course it's periodic function. Why? Because we know we did this. We already did this problem in the, just there was an addition here. Addition, with addition we did. So the periodic function, we already know that it's a periodic function of period. How much is the period? 2 pi by. Already did it. So the same thing here. So it's periodic function, no doubt about it. Similarly, go up and check the other ones. This one is difficult. This is the only difficult problem. This is very easy. This third and fourth are damn easy. Fourth we did already. It's there in the example problem. Fourth, sine was there. Here cos is there. Okay. So third and fourth are very easy. Second is only difficult for us. So let us do the second problem. Yes. Why I am saying difficult is there is a cube, no? That is why. Little mathematics. Sine cube is there. Sine cube omega t. So how do we do this sine cube, cos cube? We can't just simply say sine cube is equal to sine. We cannot say like that. It is not so simple. So what we do is we use some formulas here. Of course, you have to remember some of them. I'll tell you those formulas. It's there in 10th standard, if you remember. Sine 3 theta, if you remember. It was there in 10th standard. Let me remind you. Sine 3 theta it is called as. Sine 3 theta given as 3 sine theta minus 4 sine cube. So from that, what you're going to get is sine cube theta, you get a new formula. 3 sine theta minus sine 3 theta. Just you remember this. How you got this and all that you need not remember. Sine cube theta, whenever it comes, you have to convert like this. Then it is very easy to know whether it's periodic or not. Yes, it is periodic. It is periodic. How do I say that it's periodic? Because all are in sine, no? Each has different periods. See the first one, what is the period of this? What is the period of this? So it is as good as writing 3 sine omega t minus sine 3 omega t by 4. So what is the period of sine omega t? We know this t1 is equal to 2 pi by omega. We did this earlier. Similarly, what is the period of sine 3 omega t? It is the same as what I told you, t2. 2 pi by, instead of omega, you have to put the 3 omega. That's all. That's all. So both are different periods. 2 pi by omega and 2 pi by 3 omega. So it is, how do you take LCM? If you remember LCM method, I told you. How to take LCM? Between which numbers you have to take the LCM? 1 and 1 by 3 you have to take LCM. What is the LCM of 1 and 1 by 3? 3. It's not 3. Yes or no? How do you know that? Take LCM like this. 1 and 1 by 3. 1 will go 1 time. If you send 1 by 3, LCM, least common multiple. No? Do that. I told you that day how to do this. 3. Yes, sir. So, you know how to find out the period. Least common multiple is as simple as the highest number. You can also say that. You have done this. So understood that? If you don't understand this also, no problem, children. This is not going to come in your IP. This is just neat bit. Neat. In NEET only these type of questions will come. It's there in your NEET book today. I will send you a notebook, some of the questions from your notebook. So you can leave it. Similarly, what is the period of this function? You can see what is the period of this 3 cos something is there minus 2 omega t. See this will decide the period. This 2 omega t is there, no? If it is omega t, then the period is t is equal to 2 pi by omega. If it is 2 omega, what is the time period? 2 pi by 2 omega. So it is pi by omega is the period. So what is the period of this? What is the period of this? I'm here itself, I'm writing. Time period of this T3 is simply pi by omega. Similarly, this also I will tell you. What is the time period of this? The day we did this problem. What is that? T1, T2, T3. 3 periods will be there. First one is 2 pi by omega. Second one is 2 pi by 3 omega. Third one is 2 pi by 5 omega. Yes. Then we have to take the LCM of all of these. 1 by 3 and 1 by 5 you will take the LCM. So LCM you will take what? T1, T2, T3. What is T1? 2 pi by omega. T2, 2 pi by 3 omega. T3 is 2 pi by 5 omega. What is the LCM? 1 by 3, 1 by 5. How do you take LCM of that? Multiply this by 15. What do you get then? 15, 5 and 3. Then take the LCM. It will be easy. It is same as 15 only. What else? It's same as 15. So the LCM is 15. 1 and 3 LCM is 3. Like that. 1 by 3. 1 by 3 LCM is 1 by 3. 3. Like that. 1 by 3 and 1 by 5. 15 is the LCM. So what would be, what would you get? Period. Understood what I did? 2 pi by, instead of this one, what I would write here? This is multiplication of 15. If you multiply 15 by this and this, what will you get? 2 pi by. Okay. Understood this? We have done this. Okay. So, if you don't understand, you please ask. So these are simple type of problems. We have done these type of questions also. So I'm just seeing which all type of questions will come in the exam. Example problems, I hope you have done. Yes. Don't get you, please ask. All of the example problems. That is about 14.4. 14.5, nothing is there to do. A particle is in linear simple harmonic motion between 2 points A and B, 10 centimeters apart. Take the direction from A to B as the positive direction and give the signs of velocity, acceleration, and force on the particle when it is at. Yeah, this is a nice question. Question number 14.5. Unsolved questions are doing. Question number 14.4, 14.5. The particle is in linear simple harmonic motion. Linear means it's oscillating like this. One direction like this. Linear simple harmonic motion between points A and B, 10 centimeters apart. So the distance between them is 10 centimeters apart. If the total distance between A and B is 10 centimeters apart, what does it mean? It means that the amplitude of oscillation is how much? 5 centimeters, is it or not? That side 5, this side 5. Total is 10 centimeters. Understood that? 10 centimeter apart, then total distance is 10 centimeter between that extreme and this extreme. So what is the amplitude from the middle point? 5 centimeter. Right? Take the direction from A to B as positive direction and give the signs of velocity A to B. This direction is positive. Of course, left to right is always positive direction. Right to left is negative direction. Acceleration. What is the direction of? So if this is the direction of displacement, which direction? Then what are they saying is give the direction of signs of velocity, acceleration, and force on the particle when the particle is at first question at A at the end A. So when the body is at A, what happens to the velocity? Is it positive or is it negative? Can you tell me? When the body is oscillating between A and B, and A to B is positive, means A is only 0, 0. Is it or not? A is, no, A is not 0, 0. In between is 0, 0. In between there is 0, 0, the main position. And it is oscillating from here. Start like this. At A, the extreme position. At extreme position, A is called extreme position. At extreme position, what happens to me? At extreme position means only what? X is equal to A. It's equal to amplitude. So X is at extreme position. If X is at extreme position, what did I tell you about velocity? What is X? What is displacement? What is velocity? We derived yesterday. What is displacement? What is velocity? And what is acceleration? What are the equations for such a motion? X is given by A cos omega t plus or minus 5. So I'm writing only plus. And velocity becomes minus A sine omega t plus or minus 5, taking only plus. And A omega. You have to differentiate that. Right? So A omega. Remember also. Similarly, minus A omega square, sine differentiation is cos plus 5. Yeah, I told all this. So now what I was saying is at the extreme position, at that one extreme position, this end of it, what happens? X is what? X, what we know is this direction is positive and this direction is negative. So X is negative or positive? Negative. So shall I write it here? X, what happens to X? Ten centimeter apart. Okay, 10 centimeters. So X is negative because they only said direction from A to B as positive direction and give the sense of X is not negative. X is starts only from that position. Start from the extreme position. Space starts from an extreme position. At t equal to 0, the body is at extreme position. At t is equal to 0, this is t is equal to 0. What are they asking us to find out? Signs, such as sign of velocity, acceleration, velocity and acceleration. Velocity at extreme position, what happens to velocity at extreme position B? You check this equation. Velocity at extreme position is what? Minus. So it is minus. And what about this sign doesn't exist, extreme position? What about the acceleration? Yes or no? At the extreme position. Understood that? Both are negative. Extreme position. Velocity is also negative. Acceleration is negative. Because of this sign. No, because sign becomes what happens to sine and cos, you have to check that one. Are you listening? So like that we have to do the remaining ones. At extreme position A. Then they asked at B. At B what happens? At other extreme position. Other extreme position B, what happens? Reverse. What happens here will have happen reverse there. So velocity will become, acceleration will become. So whatever happens at A, reverse will happen at B, is it or not? So like that, those two questions are important, so I brought it. Similarly, another question is there. Next question number, teaching only unsolved children. Solved you can do. 14.6. We have the book in your hand, you can check all this. Which of the following relations between acceleration and displacement x of a particle involves simple harmonic motion? Very nice question. Wonderful question. You see. A is equal to 0.7x value. Which of them represent SHM? No, this is not SHM. No, not SHM. Why? How should it be? It should be A is equal to something minus and then there should be an X. Second question is A is equal to minus is there. Yeah, that is SHM. Minus 200x square is there. So this is also not SHM. Not SHM. Because X should be there. Not SHM. A is equal to minus 10x. Is it SHM? Yes. Yes. It is SHM. This is such an easy question. Fourth question. A is equal to 100x, not SHM. SHM means some minus should be there, X should be there, and some number should be there. Yes, only one of them is existing like this one. Rest none of them is there like that. Minus 100x cube they give that also. So it's anyway not SHM. Motion of a particle undergoing SHM is described by X is equal to A sine or A cos omega t plus or minus phi. You know this. It's not a question. Question number. Yeah. Question number 14.8 is a numerical. We are only doing numericals right now. Theory questions are not doing. Theory questions are already doing. A spring balance has a scale reading. Spring balance. Scale reading means on the reading it is shown. Scale reading 0 to reads spring balance scale it reads 0 to 5 50 kg. 0 to 50 kg. Length of the scale is 20 centimeters. Length of the scale. Length of the scale. 50 centimeters. What is the force acting on a spring balance? F is equal to minus kx. X is the extension. Okay. Length of scale is 20 centimeters or more. Total length of the scale. Length of the scale is 20 centimeters. Body is suspended from the balance when displaced and released. When displaced and released means you pull it down like this and leave it. Then what happens? It undergoes up, down, down. Released. Oscillates with a period of time period they give. 1 seconds. They gave the question. What is the weight of the body? So what is the weight of the body? They ask. Weight, what is the formula? mg. Mass of the body we still don't know, remember? But we know time period is related to mass. How is time period related to mass? 2 pi root k by m or m by k? Yesterday I told, check your notes and tell me. Root or 2 pi root m by k. Yes or no? We did this. M, if we find out, we have done the problem. K, force constant, we know. How do we know force constant? K. Force constant, what I told yesterday, total force acting by total extension. Total force acting on the body, but total extension that's possible. Total force is how much? 50 kg. 0 to 50 kg. This is the spring balance is a scale that reads from 0 to 50 kg. So 50. Total 50 kg means 50 force. Kg. By total length how much? 20 centimeters. So what we have to find? Newton per centimeter. When centimeter we cannot do. I told you that centimeter we cannot do a problem in centimeter. Convert that to meter. So what do? 10 newtons. Because kg meter per second square is newton. By 20 centimeters is 1.2 meters. So now it's correct unit. P into 10 is how much? 500. This is your force constant. Understood this? This you have to substitute here to get the answer of mass. Then you will get the weight of the body. This seems little difficult and big, but it's not difficult. It's only that you have to do. It's a long problem, but it's not difficult problem. Only seeming lengthy. So 0.6 is there this side. 2 pi is there here. Mass we don't know, but K we got it. 500 by 0.2. Now what do? You find out the mass. How do you find out the mass? Squaring on both sides. Do that. 0.6 square by. Are you understanding? 2 square 4 pi square, no, that will come this side, is equal to m into y. Understood that? Are you able to hear? Understand? Any doubts here? Just keep on teaching. Are you listening? Are you understanding? So what is the mass? From this we get the mass. By find out this, you get mass. Some mass will come. Find this mass, you can find the weight of the body. What is the weight of the body? mg, mass into gravitational acceleration. This is mass. No? Divide, multiply this by 10. Divide to 10. Then you will get weight. Understood that? This multiplication I am not doing. You can do it in calculator. You will get it. So it's very simple. Just cut this 3 times. Yes. 4 and this will cut 250. 125. Nothing else can cancel. Nothing else will cut. Pi square is there. Pi square is almost equal to 10. Do you know that? Pi square is how much? 3.142 into 3.142 you do means you get almost 10. This 10 and this 10 is cancelled. So what you will get? Approximate answer is going to be 125 into 3 into 4.6. This will be the weight of the ball. This many kgs. So you do this answer. Okay. Okay. Next question. So the tough ones I'm not doing. Only the IP 11 questions only I'm doing. Question number 14.9 also IP question. Spring having a spring constant. Spring having, they gave this diagram of the question. Spring having spring constant is force constant. They only given the question 100. Is mounted on a horizontal table as shown. The body of mass 3 kg is attached to the free end of the spring. This is the mass. 3 kg attached to free end of the spring. Mass is then pulled sideways. By a distance of this extension they give 2 centimeters and released. Then what happens? It undergoes ascension. Release. Then determine frequency. Asking you a question they asked. Determine the frequency. Then maximum acceleration of the mass. Maximum acceleration minus omega square x. Maximum means what? Minus omega square into amplitude. That is called maximum acceleration. Maximum is omega square into amplitude. Maximum acceleration of the mass and also maximum speed they are asking. One question is maximum speed V. What is maximum speed minus omega into A? This is called maximum speed. Okay, these they are asking to find. They give K, they give mass, they give extension. Understood the question? So what we got to do is find out the time period first. Find time period, you find everything else. 2 by root over m by k. That's the formula. 2 by root over m, you know, 3 kg. K we know 100. Cut it, 400 will come. So 2 by root over 1 by 400. 400. 20 is a 400, no? You know that? So the square is 2 pi by 20. Pi by 10 seconds. Time period. So obviously what is frequency? 1 by time period. So 10 by pi. Hertz. Hz you should say. Frequency is depicted as hertz or second inverse. Hertz or second inverse. Is that clear to you? Okay. Now rest all things they're asking. Rest all very simple. If you know time period, you know everything. What is actually time period? So what is omega? So 2 pi by time period, you know. Pi by 10. What do you get? 20. 2 times 20. Radians per second. This is omega. If you know this, second bit you can do. Acceleration is known as what? Minus omega square A max. Understood that? What is that going to be? Omega we got. And what is acceleration? 2 centimeters. Acceleration is the 2 centimeters. Amplitude is the 2 centimeters. So this is 20 square minus square into 2 centimeter means how do you write that? 2 centimeter, 0.2 meters. Understood or not? Understood? So you multiply, you'll get that. Similarly, third bit of the question. Vmax. What is Vmax minus? What is minus C omega? A. Omega, we know 20. These multiplications are not there. 0, 0 if you cut it. So 4 2s are 8. So minus 8. What is it? Acceleration means meter per second square. Velocity means what? 0 if you cut it. 0.2. 0.4 meter per second. Is that clear? Velocity you take positive. Is that understood? Clear? This completes one of the most important problems. Let us see any other problems. So this chapter almost concludes here. To see any other problems of this chapter, if you have any doubts, you can ask me. For the time being, let us start the next chapter or most important chapter. What shall I do now? Which chapter do you want me to teach next? Start next in the chapter. Could you answer, please? What happened to your voice? Not working today?
Like sir, you mentioned that you couldn't hear me, right? Hello?
Mechanical properties of solids, mechanical properties of fluids, thermodynamics, kinetic theory. Which chapter you want me to tell next? Hello, are you there or not there? Answer. Mechanical properties shall we start. The next chapter is mechanical properties. We start. It's also called as elasticity. Also called as elasticity. Let's go down here. These problems you please do and tell me. Any other which you did not get or any doubts you should ask. Okay. Almost every problem, every model I covered. The next chapter is mechanical properties. I will start as usual. Mechanical properties of solids, also called as elasticity. Elasticity. Every day in our everyday life we call elastic. This body is elastic. This body is stretching. We call no, we continuously we use this word in our everyday day-to-day life. Yeah. So that is very small chapter. This is the smallest, easiest, shortest chapter actually. Very simple chapter. Especially for NEET exam, the most easiest chapter is this one. Mechanical properties of solids. So shall we start it here? Or you want me to go down a new page you want? Let's start a new page. Mechanical properties of solids. Also called as elasticity. Okay. Fluids, you want fluids, actually you want fluids. Okay. Right. fluid dynamics, it's also called this. What about the solids thing? You understood that? This is also simple chapter only, fluid dynamics. It's also called as fluid dynamics. Very simple chapter. This is everyday, in your everyday life. From 8th standard, you have some knowledge about this mechanical properties of fluids. Every day in our daily life, when we are bathing, every day, you are experiencing this thing, mechanical properties of fluid. So I'll show you what it actually is. If you, for example, a container, I make a container of water. Tub or what's. So there is something, some container of water or any liquid. Now, every day our observation, when we try to dip something in it, what happens? It will not go easily. So if you put your hand in water, just put your hand, insert your hand in water. What happens? You will feel that your hand is experiencing a force and it is being pushed away. Is it or not? It's everyday observation. So that push that your hand is experiencing is because of this. Water is only doing that. Water is pushing your hand outside. That push that you are experiencing or reducing of your weight, reduction of the weight of your hand, weight of your hand. You feel this is everyday observation. Is due to what? Is due to the buoyancy force. Buoyancy. It's also called as buoyancy. The force of buoyancy. A buoyant force. Have you heard this word anytime? Buoyancy. But that's what we are trying to understand. Buoyancy means the force with which the hand, every day we are hearing this. Force due to buoyancy. We say this. Something, your weight is reduced, no? Weight seems to be reduced. Buoyancy. This is only called as Archimedes principle. The Archimedes principle says this only. Buoyancy force, about the buoyancy force. Buoyancy force is basically the force with which any solid experiences a upward push from the liquid. When you try to push something into the liquid doesn't allow you, it will try to push you away. You in swimming pool, you'll observe this mostly. In swimming pool, not only in swimming pool, even in your bathtub. That is the experiment of Archimedes. No? I hope that's a very wonderfully known experiment. Archimedes was bathing in a tub and he suddenly got an idea that the water is overflowing out of the bathtub because his body is immersed in water or that liquid. That is where the water came out. So he got an idea that we can use this to predict and exactly calculate the density of gold. We can use this phenomenon. So why does that happen? That is because of the principle of buoyancy, and this also called the Archimedes principle. So let us understand that in detail. So the liquid displaced, displaced. Some of the liquid is displaced due to what? due to the immersion of a solid, due to the immersion of a solid, some of the liquid is displaced from its original place. Therefore, the weight of the body is less. Weight of the body, which is the solid body, is reduced by by how much it is reduced? Weight of the body, for example, 10 kg. 10 kg body is there. You put it in water, you will not weigh 10 kg. You will feel it is some 8 kg, 7 kg, something like that. Why? Because the reduced weight that is reduced is due to the equivalent amount of water that is being displaced by the volume of this immersed solid in that liquid. Understood? The weight of the body is reduced by the equivalent volume of the water. Weight of the body is reduced by equivalent weight of the volume of water displaced. It will depend. Yes, it depends upon the salinity of water. It depends on density of water. It basically depends on density. No, you can see in swimming pool, you can easily dip into the you can dive into, but in saline water like beach, okay, you can't easily dive into. It's not possible because the higher the density of water, it's not easy to dive because the density is more. No, density is more. So it will not allow the solid because more buoyancy force it will show. The upward buoyancy force will be more. So your weight will be reduced. So more the density, it's very difficult to dive into the deep layers. That's why it's not so easy to dive into oceans. Where it's very easy to dive in a swimming pool. It is easy to dive in a river. So you learn diving in a swimming pool and you think you can dive in a river. It's difficult because the salinity of river is more than that of the swimming pool. Similarly, you may have learned diving in a lake or a river or a pond. You still can't dive into or swim in a ocean. That's not possible so easily because the salinity is very higher there. So density of the water. What you're talking salinity is density. Density of water decides everything. Density of water only tells you everything because the density of the body. The reason is this. See, the reason is this. Density of body immersed is generally more than the generally more, isn't it, or not? Generally more than the density of water. Obviously. Achha, you know about this Dead Sea, I suppose. Dead Sea. That's what you're. That's the best example for you. You can see in YouTube this thing. Dead Sea. In Dead Sea, you can't. Why is it called Dead Sea? Do you know? Because the density of water of Dead Sea is very high, so much high, the salinity is so high that nothing can die, nothing can sink into it. Nothing will sink. Nothing will sink. So that is a problem. In Dead Sea, you can't go, you can't row in a ship because ship has to sink a little bit. Ship won't sink because the Dead Sea density is very, very high, extremely high. It is the saltiest, highly saline. So the density of the water there is so high that nothing will sink. Everything will keep floating. Even some type of metals also will float. So that is the problem. Understood there? Same thing. So now we must understand the density. What you're calling salinity is density. So now we are going to understand what is this concept of density. Density is represented like this. Rho. Density rho is given by mass of the body by volume. It is defined as what? Mass per unit volume. Defined as per unit. Density is defined as mass per unit volume of the body. So now these are very important that you should know about density and you should know about pressure. Pressure. There is another concept called as pressure. You know what is pressure? Pressure, I will tell you about pressure. See, once you go into the deep layers of water, you will experience a concept called as pressure. Not only in the deep layers of water, whenever you dip yourself into water, you might have, I don't know whether you've ever done swimming pool, swimming, you understand what I'm talking about. In swimming pool, if you dip little deeper, you will feel that your head will, you will feel something, you feel like your head is put in between two nuts and bolt and they are tightened up. That is because pressure. Your your body is experiencing a pressure. Pressure. Why is this pressure there? Because each and every molecule of the water is trying to push you out of the water. That is why you are experiencing a pressure. Understood? And pressure is given by the force experienced, force applied by the unit area. So imagine decompression sicknesses. So imagine, for example, force experience means. So, for example, if you just inside water, if you spread your body, then what happens? If you spread your body, like you see Ramdev Baba, person who does yoga. If you spread your body inside water, what happens? Area increases, is it or not? Effective area increases. So then what happens?
Yes.
Pressure will be less. Because force per area as the denominator increases, what happens? Tell me. As the denominator increases, pressure decreases. That's why these yoga babas and all that, they'll spread their body. But when you, if you strangle yourself like this, like for example, you try to put your body nearby, very nearby. You come nearby, like a alphabet 6. Then what happens? Your area is reduced, you will experience a more higher pressure. Because area increases means pressure decreases. And area decreases, pressure increases. That is why at the deep layers of water, these fishes like whales and other any of these spread out area animals cannot sustain. Whereas that animals like this eel, have you heard about eel? Electric eel, we call it electric eel. Electric eel, jellyfish, these can happily survive. Why? Because their area is very high. As area is high, pressure on their body is reduced. So they can still survive. Humans cannot survive at the deep layers of water because the human body is not like a flat thing. If you have a flat area, pressure on your body will be so less. You won't feel much pressure, like a paper, But our body is not like that, our three-dimensional body. So we will experience a high pressure. Understood that? So that is what is concept of pressure. Understood that? So pressure is defined as what? Two definitions are there. The mathematical definition is change in the force by change in the area. It's called as change. Change in the force change in the area. This is one force. This is one definition of pressure. Or limit. Limit. So this is also simply change in the force by change in the area. So now you understood one thing. Pressure. What is pressure? You understood. What is density? You know, density is mass per unit volume. I don't know what is density. Simply, you tell me. Oil is more dense or water is more dense? Thickness. Thickness. Oil is very dense. It's very thick. Water is less density. What is the density of water? Do you know that? Density of water, pure water. Density of pure water in CGS system. CGS system is 1 gram per 1 centimeter cube. In MKS system is 1000 kg per MKS system. So now how do you measure pressure? There should be some formula no, to measure the pressure. So simultaneously, I'm just telling those problems also so that we add it easily. So there is one small problem they're giving here. They're giving two area two high bones femurs, each of area of cross section 10 centimeters square. So area is about 2 into 10 centimeters square. Two bones, two femurs. Two femurs, you have two femurs in your body. 2 into 10 centimeters square support the upper part of the human body of mass. Estimate the average pressure sustained. Pressure average. What is pressure average? Force per area. Pressure is force per area. What is force acting on the body? On this famous 40 kg weight. 40 into kg. 40. This is mass, no? Kg. 40 into 10 divided by area. What is area? 2 into 10 centimeter means what? I hope you know. 2 minus 2 meters. I hope you know. 1 centimeter is 1 by 100 meters. Do you know this? So that's what it is. So now what is this? This is Newton. So the unit is Newton per meter square. This is how much? 0 you can put. 4 you can put. So you got 20 in the numerator. Newton per meter square. 10 power minus 2 becomes 10 power minus 4 because square is there. So what do you get there? 2 e into 10 power minus 4 becomes plus 4. Newton per meter square. So did you understand this? And write this as 2 into 10 power 5 per meter square. This is called as Pascal. The unit of pressure. 1 Pascal, PAS, Thomas M. Pascal. So 1 Pascal is given as 1 Newton. 1 Newton is called as 1 Pascal. This you know, I think so somewhere you got it. 8th standard is it? What is a Pascal? So now Pascal has given a law that's called as Pascal's law. Pascal's law. What is Pascal's law? I will explain. Just listen and understand, then we can do the definition. For example, you have a container, or you are in a swimming pool. You are in a swimming pool. You are diving into a swimming pool. You are in a little bit depth of swimming pool, inside water. What would you feel? You would feel that the water is exerting some pressure on your body. You will feel entirely your skin is being experienced in some type of a push by this water. Wherever, everywhere you will feel the same pressure. You won't feel different pressures in different parts of your body. No, it doesn't. It doesn't happen like that. So that is what is Pascal's law. Pascal's law basically is what is Pascal's law says that it is a proof that clearly says that a body experiences pressure equally at every part of the body. Body experiences pressure equally at every part of the body. No, not be different at different parts of the body. So now we took a What is this called as? Shape called as pyramid. Pyramid shape. You take a pyramid shape. So now what we are doing? The pyramid shape one. Of course, my diagram is not so good compared to your textbook diagram. So the water is exerting pressure on each and every face. Water is water. Which you pyramid shaped body you are immersing in the water. Then you want to find out pressure. Pascal's law is only that. Pascal's law is also called as the proof. The Pascal's law states that a body experiences equal pressures at every part of the body, irrespective of the area. Irrespective of the area, all yeah, every surface will experience the same pressure. So here there is one angle. No, this pressure. What is pressure? This is a force F. This is a force. Surface B. This is surface B. This surface. This green color surface. Pink color surface. And yellow color surface. Three surfaces itself. So F due to B. This is the B surface, green color surface. And the pink color surface, F force due to A surface. Force on A surface. Force on C surface C. So let us find out the forces. Let us find out the different forces. All are different forces. FA is not equal to FB is not equal to FC. Different forces. But then, even though they are not equal, see now, you must know what is basic trigonometry, then otherwise you cannot do this. Not the day. So basic trigonometry if I use. This force will, this derivation is not done properly in your textbook. Okay, I am doing it now. They have not done that. Just simply gave it without any understanding. So this is theta. So there is a theta, no? See, this theta 2 will come here, no? Similarly, this theta 1 will come here. No, you see, this force FP is like this. We split up as two components. One force this way, one force this way. What is this component? Theta 2. Theta 2 will be, I told you, FP cos theta 2. Why is it FP cos theta 2? Why? Because it is called as horizontal component of force. Understood that? Side force, this direction. Is that clear? This area, this green color area is there, no? This area, green color. This is the area of the pyramid base, inclined plane. This area AB can also be split up as two components. How? Area also. This is the area, no? Area vector. Area vector will be like this. Will also split up as one component like this. Component like this. Yes. How will that area split up as two components? AB also split up as two components. How it is split up as, see that angle we get the theta 2. The same theta 2 is this theta 2. So see, this is your A area. And this is FP. FP are split up as two components like this. This is the theta with which you are split up. This is the theta with which you are split up. Comes to this theta 2 is this theta 2. So this area also is split up into two components. How it is split up? This side, one component, this side. This side, what is the component? AB. This is AB. This is called area vector. Area vector. Area vector is split up as two components. What will it split up as? This is called cos component, this sine component. AB, sine component. Sine theta. Okay. AB sine theta. And AB cos theta. AB sine theta will be equal to AC. What is AC, by the way? What is AC? First of all, this AC. What is AC? Similarly, another component AB cos will be equal to area A bottom surface. So this is by geometry. How I got this? Simple geometry. Similarly, A, this force Fi is split up as two components. One is this side, another component is there. Side. Sin theta. 2 or theta, let us call theta. Theta. Okay. Understood this? Now, if you see carefully, no, see carefully, two forces are there. One force, Fc, is like this, and opposite to that one force is there. Fc is opposed by what force component? Fb cos theta is opposing Fc. Is it or not? Did you understand? Similarly, two vertical forces are there. What is that? Fb sin theta is opposing upward force. What is that? Fa. Yes or no? Yes. So finished. We got it. So Fb sin theta will be equal to Fc, and Fb cos theta equal to Fc, and Fb sin theta is equal to Fa. Understood that? So when these two are equal, these two are equal. That's it. Okay. So we write that as P cos theta is Fc. Similarly, Fb sin theta is Fa. Is this understood? And we also have already the area vectors also. Area AC, we have split up just for AC is equal to AB sin theta. What is AC equal to AB? Similarly, A cos. We know this. Now, if you see this, you understood. You understand this? P cos theta which theta I have taken. He has taken see there are two thetas. It's not that. Okay. My cos will become sine and sine will become cos because see, he has taken this downward component, downward theta. So cos theta will become sine theta for me, sine theta will become cos theta for me. So that is why you have to write this as cos, and my sine and cos will change. Sine will become cos, cos will become sine. Because downward thing, he has taken this as theta. Okay. So no problem. Anything you can take. One of them you should take, that's all. Understood that? So FC will become here also sin theta. Which is theta according to our consideration? This is theta. Understood that? Sin becomes cos becomes sin. Now you see, you divide this equation 1 by equation 3. That's no derivation is finished. Divide, you know, divide equation. That's consequence. What do you mean? V is equal to FC. Is the same as E by AB, same as A by AA. Did you understand that? So what does it infer? The pressures are equal. So this clearly infers that. This infers that pressures are equal. That's pressure of B. Pressure on the surface B. What is this? Capital B. Pressure, not power. Pressure on surface A is the same as pressure on surface B is same as pressure on surface C. So pressures are equal on all the surfaces. This is the proof of Pascal's. Understood? This is the proof of Pascal's. Did you understand that? Now it is 6 o'clock. One class is finished. Do you want me to give a break and start the next class? 6:30 shall we start? Will you be ready? Okay. Today, next class we will finish up this. Very small chapter. Almost will finish. Not a big deal. So one class is already finished. Next class 6:30 shall I start? 6:20 you can tell me.